Welcome everyone to the demonstrating implementation stream of the SNOMEDCT Virtual Expo 2020. My name is Donna Morgan and I am a mapping terminologist at SNOMED International. I will be moderating today's session, and can I request that you please use the question and answer box to type your questions to our presenter in this session. So I would now like to introduce you to Pawel Paczuski. He is the CEO at SNOMEDCT, and he is going to present a presentation for us entitled Entity Tagging for SNOMEDCT Concepts in Text-Based Telemedical Solutions. Thank you, Pawel.
Thank you very much for the introduction. I'm from SNOMEDCT, and this is a startup that focuses on creating medical documentation that is meaningful for the computers. We try to structurize it as much as possible so computers can understand it and we make doctors more productive thanks to it. I also created this presentation with help of Arthur Kusak, who's from Medical Center di Medici in Łódź, Poland. This is a network of clinics that and they already have 20 years of experience helping patients. So we together learn with each other and we make software solutions that make doctors more productive and the documentation more meaningful. And today I'd like to show you some solutions that we created, and this is Entity Tagger for SNOMEDCT concepts in text-based telemedical solutions. COVID-19 changed a lot in modern medicine. We can see that when the COVID struck, we could observe that there was a huge spike in interest in telemedical solutions. Later, it dropped, but it is still twice as interesting for people to look for in Google as it used to be. Unfortunately, thanks to COVID, people are more aware of telemedical solutions and their possibilities. And because of COVID, it is sometimes the only available way of communicating with clinicians without risking anyone's life. Telemedicine is not good for all applications. It is not good for emergency situations, but it is especially suitable for telemedical advice. However, this is not the most popular way of contacting with the doctor online. The teleradiological advice focuses on helping patients look for teleradiological information online without meeting with radiologists. It is often used as a way to make sure that opinion of one radiologist is something that is fully correct, so the patient can ask for advice another radiologist, and if their opinions match, the patient is more aware about decision about their medical condition and their treatment. We analyzed the most popular workflow of teleradiological advice, and it looks like this. A patient has to initiate the appointment. They have to request an advice from the clinic. It is done via phone or via a form on the website of the clinic. The clinic is then responsible for billing the patient, and then they pass patient's phone number or some other contact to the clinician. And when clinician and patient are available, they can call each other. And then clinician asks for patient observation. They can ask for existing documentation, imagery, and other radiological reports. And also, of course, patient answers the questions. They also submit the medical documentation they already have. After collecting the information, a clinician can formulate the advice, and they simply tell it to the patient. Everything is being recorded for the auditing purposes. What we observe is that the good parts of this approach are that this is very similar to the traditional appointment with a clinician. It only was changed with the way of communicating. The patient and clinician use phone, Skype, or any other online tooling. It is also easy to make an advice for untypical cases because clinicians can ask for further explanations. They can react to patients' answers and ask them more thoroughly. What is bad about this is that it is a synchronous way of communicating. Both patient and clinician have to be present at the same time, and they have to be fully engaged in the communication via phone or using video call. It is the information that is extracted from patient is stored in recordings, so it is difficult to mine those recordings for information when we want to simply look at the output of patient. Sometimes it is difficult also to exchange files and other types of medical documentation using those tools. What we propose is to change this workflow to make this more asynchronous. And this looks like this. We introduce a system between a patient and clinician, and this system is responsible for the interview with the patient. The interview is quite complex, and it formulates its questions based on answers to the previous questions. So we can make the interview more detailed based on answers formulated by patient. So the patient can request an advice, then they answer the medical interview. They also submit the answers to the system. They can attach existing medical documentation to their answers. The system stores all of these pieces of information and then bills the patient. And what we introduce here is that we add the SNOMEDCT entity tagging that I will explain later on. When the clinician is ready, they have some time, then they can get the package of data from patient and at a single time, without asking for any other explanation from patient, they can prepare the advice and submit it immediately to the patient via email or any other communication means. After that, the patient can also say how they feel about the advice. So we have the feedback from patient, how satisfied they are. The good and the bad things about this workflow is that, first of all, the good ones are that clinicians are no longer responsible for collecting the information from patients. We create an interview that is detailed, and the questions are formulated after knowing the answers to the previous ones, so they form a decision tree. Also, it is, as I already said, asynchronous. So patient and doctor do not have to be present at the same time. They can patient can fill in the survey at any time. The system collects all required information, and then only after that the clinician can formulate their advice. Also, what is important, patients become one of the authors of the medical documentation. Doctors create the advice, but they also attach the answers from patients. So we can see the precise formulations used by patients when they were describing the medical condition. What is bad about this workflow is that it requires falling back to the traditional video call or phone call when something very unusual is happening to patient and is not covered by our medical interview. There is also some learning curve attached to this workflow because the doctor has to learn the tooling. They have to learn to understand the questions and what are the typical answers provided by the patient. And this is what a typical survey with the system looks like. We can see that it is in the shape of a tree. At the top of the tree, we have a question that the patient starts with, and based on the answer, in this case, true or false, the surveying mechanism proceeds to the left or to the right question. And there was one thing about attaching this SNOMED CT concept to the patient's answers. And why should we do that? First of all, when we have SNOMED CT concept attached to the patient's answers, we can attach some priority to the concept, to the SNOMED CT concept. So we can then prioritize having a list of many patients' answers. We can prioritize which patients should receive their advice first, because of the importance and the time required to deliver the advice. Also, when we have SNOMED CT concept attached to those answers, we can automatically map them to the ICD-10 terminology. So in several countries, the ICD-10 is used for billing. So we can automatically estimate what is the price for the medical service. Also, we can detect lies in patients' answers, because sometimes the answers may conflict, and a system that's aware of SNOMED CT concepts that are in contradiction to each other may find these lies in medical documentation created with help of patients. It is also useful for auditing, because we can estimate the price of the medical service provided by a facility, and we can see what exactly was the price calculated by the facility, and we can look for huge differences between those two prices, and we can look for medical facilities that are candidates for auditing. And how to attach those SNOMED CT concepts to plain text phrases that are supplied by patients when they are answering. We observed the nature of the problem, and what we saw was that the documentation created by patients can be split into two parts. In this slide, those two parts are in different colors. The red ones, we call them medical concepts. Those medical concepts serve as introductory phrases for a more detailed description of patient state. So we can see that there are phrases related to medical examination, like computed tomography of the chest, or phrases related to organs, right, like right lung. And between those medical concepts, there are those yellow pieces of text, and we call them contexts. They are more detailed explanation of the medical concepts. First of all, we try to fuzzy match the medical concepts with SNOMED CT concepts, and then we proceed to further analyzing the contexts. And we know that they may contain not only one SNOMED CT concept, but many of them. So we try to further split them into several phrases, and we use fuzzy matching for this. What we did is we tried to create a machine learning model to recognize those medical concepts in unstructured medical documentation. We used for it 100 labeled radiological reports that were machine translated into English, because they were originally written in Polish, and they contained around 3,000 medical concepts and 3,000 context between them, because with one concept there was one context. We used a library called SPACY that focuses on providing natural language processing tooling for production-ready solutions, and we used English language model in order to make entity tagging for those medical concepts. We used existing model that had several types of entities already introduced, but we tried to add another one, which was our medical concept. So the whole task was about learning, teaching the model to use another type of entity, to entity tag with an unstructured text. We also use PyMedTerminal library, which is a nice tool to load and query SNOMEDCT. So we didn't have to rethink the whole schema for database in order to load the SNOMEDCT. Everything was provided by the PyMedTerminal, so we could focus on the natural language processing pipeline. And also, when we had those contexts split into phrases, we used some tools like fuzzy search in order to fuzzy match for those phrases with SNOMEDCT. We created SQL queries that then were matched with the SNOMEDCT concepts. What we observed that when we tried to extend the existing model with another type of entity, this med concept, we saw that it started to forget what it already knew. There were some other types of entities like numbers, like names and surnames. And when we trained our model, the existing model that we used with transfer learning started to forget. And we fixed this with a solution called pseudo rehearsing. It was like this: we simply we copied several Wikipedia articles. We used this model to do entity tagging for this contents of those Wikipedia articles, and we used those tagged articles as a training set. So when the model was trained to use to find new type of entity, this medical concept, it was also rehearsing what it knew about the existing concepts. After that, we use those contexts between two medical concepts. We split them into noun chunks, and also SPACY was trained to do this with some deep learning models. And then after we had sentences, context split into phrases, noun chunks, we matched them using fuzzy search with SNOMEDCT concepts. What we did in order to measure the success of our solution was to use we used three measures: precision, recall, and F1 score, which is simply harmonic mean of these two. And we also compared our results with others, and it was quite surprising for us that not many people publish their result in this area of application. But we found one article which had about the F1 measure about 70%. What we achieved was 80%, so we have 10% more with our model. And summing up, we could observe that the problem of tagging SNOMEDCT concept in unstructured medical documentation is quite difficult, but there exists already tooling that allows us to make this much easier. We can load SNOMEDCT using existing tools and use those other general purpose tools to query it, to load it. It is quite easy to do this, and there already exists free tooling for it. And when we have those SNOMED CT concepts attached to the unstructured medical documentation, we can use this as the platform for such interesting solutions as automatic triage or patient slide detector, some auditing, etc. From my references list, I would certainly encourage you to look into this Knowledge Engineering with Semantic Web Technologies course. It is available on YouTube, and it is a great introduction to ontology search, which is very useful for SNOMED CT applications. Should you have any questions, or if you are interested in solutions using SNOMED CT, I'm very interested in discussions about this. You can contact me anytime.
Hello. Thank you very much for that, Pawel. Very interesting. Hopefully everybody can hear me now. We're going to go into the question and answer section of this session, and just to remind everybody that we do need to finish by the 30 on the half hour. Okay, I've got some questions to work through. The first one is from Manisha. She says, thank you very much for this presentation. What is your experience in adopting asynchronous teleradiological advice where patients want generally attention of the clinician? In fact, synchronous teleconsultation before COVID-19 pandemic was not adopted due to the patient's needs of having physical interaction with clinicians, or not adopted very much.
Yes, first of all, COVID enforced some change in the way we think about teleconsultation, especially when all the lines were busy because everyone wanted to have some consultation. But especially the asynchronous teleradiological advice is not for any use case. What we observe, we deployed the solution in the medical center di Medici in Łódź, Poland, and we observed that it is not for any use case. And the most useful use cases are when you want to peer review some existing documentation you got from another radiologist, and you want to make sure that their advice is correct. And this is done by another radiologist, and you can compare what they suggest to do.
Okay, thank you, Pawel. A second question then from Manisha. She asks, which AI algorithm are you using for this work?
First of all, this is the part of the AI connected with machine learning, and especially with natural language processing. And this is closely related to the problem of entity tagging. This means that we have unstructured text, and we want to find types of things called entities that we know how to recognize. And we used for this model trained on medical documentation, which recognizes a new kind of entity, and we call this entity medical concept. I hope this answers your question.
Thank you. Moving on then, another question here, which is from Anthony, and he asks, there are a lot of radiological features which are present in radiological reports which are not SNOMED terms. How do you overcome this?
Yes, that's a great question. There are a lot of such phrases which cannot be mapped onto SNOMED CT, and the information we extract from the patient is eventually read by radiologists. So it is not crucial for us to map all phrases that are included in the report to SNOMED, but what we manage to tag in those documents allows us to estimate many things, like what should be the price of the service or any other things, or like auditing. it is only like an approximation of that. If we want to be 100% correct in any case, this would require a lot of new concepts in SNOMED CT, but this is still something that should be improved over time.
Thank you. A question from Stefan now. You translated your texts from Polish to English. Do you think that this works so well that, at least for your use case, SNOMED localization is no longer necessary?
I think that SNOMED CT localization still is necessary. There is Polish localization being developed, not present for usage, but again, we only can approximate right now. What we already achieve is something okay for our use case, but if we want to make this solution more comprehensible, we would need this SNOMED localization for our language.
Okay, thank you. And I think we've just time for one last quick question, if that's possible, from Anthony, who asks, thanks for the talk, very interesting project. How does this system distinguish between the context of the entities or SNOMED terms, for example, this chest X-ray is negative for COVID-19, or the patient's sister has COVID-19?
That's a very interesting question, and the answer for this would be quite difficult and even not precise, because what we try to find in those medical documents is a thing that we trained our model to look for. I cannot answer for the model we trained, because this is something fuzzy. We only can expect our model to answer our questions in certain way. I wouldn't bet any money on what this system would answer in the example you provided, but it should be. I can say what we should expect from this, and this phrase should be recognized as a context in the naming I defined during the presentation.
Okay.
I hope that answers your question.
Thank you, Pawel. Thank you very much, everybody. Thank you for the questions. Thank you to Pawel for his presentation, and thank you for everybody who attended. We'll draw this session to a close now. Thank you.
Thank you very much.
Thank you.